Hello, you are welcome to my channel. Today we continue with special curves, and the special curve we are looking at is hyperbola. A hyperbola is the locus of a point which moves so that its distance from the focus is constant and greater than 1 to its directrix. That is, the eccentricity of hyperbola is always greater than 1, that is 3/2. So we have a question here. The question says draw a hyperbola when given the focus 20 mm from the directrix and locus points from the focus to be 15 mm, 20 mm, 30 mm, 40 mm and 50 mm. So these are the focus points that are given to us. So we'll be working with this focus point. So we have to construct this one step after the other. So the first thing we are going to do here is to draw the given focus from the directrix. So we are going to draw a directrix or the director. I have a line. This way. Locate a point on the line. Okay, same this part. Then we draw a horizontal line in that way. So this is the direction line, directrix. So from the directrix we are going to take the focus, which is 20 mm from the directrix. You can see it's given in the question, draw a hyperbola when given the focus 20 mm from the directrix. So we go this way. From the directrix I will measure 20 mm to centimeter, that is 2. So from this part I'm going to produce a vertical line up, which will serve as the focus. We have this up, then we can extend the line down with the ruler. So the next thing for us to do is to divide the distance between the focus. This is our focus. The distance between the focus and the directrix into ratio 3:2. So we are going to use method of line division. From this part here, draw another line. Then we are dividing, that means we are going to be stepping up first into 5 equal parts. Okay, we are dividing this because when we add the ratio, like I told us in my previous video when I did dividing a line into ratio. So let me quickly do that. You can contact the video for explanation. As you can see from the focus point, I've divided the line into ratio 3:2. That is 1 from the focus, 1, 2, 3. Then this other side, 2 portion, 3 portion, 2 portion. So the next thing I'm going to do is considering the following locus point. This means that the locus is always 2/3 as far from the directrix. Now we have the focus points given to us. We are going to be doing a little calculation here: 15, 20, 30, 40 and 50. So we are going to divide each locus point by 3/2. 3/2, that is the eccentricity of hyperbola. Okay, so for the first one here, if we divide 15 by 3 over 2. Mathematically, this becomes 15 times 2 over 3, and that is 30 over 3, which is 10. The same thing is applicable to 20. So very quickly we have 20 mm times 2 over 3, which is 40 over 3, equals to 13.33. So let me quickly do other calculation. So these are my results. So we are going to be working with this 10, 13.33, 20, 26.67, 33.33. So this is our vertex of the hyperbola. So the next thing I will do from here, making use of each of these values, I will measure. The first value there is 10. So this is 10. From that point, I'm going to draw a vertical line up in that format, then extend down. So the next number is 13.33. So that's approximately 13.3. 13.3. This is 1, 2, 3, 13. So 13, approximately 13. So I will draw another vertical line up. So the next number is 20. So I will do likewise. The 20, if you are to measure it, is falling on the focus point. So I don't need to do that again. If you measure 20, don't forget that our focus is 20 given to us from the question. So the next thing is 26.67. So this is line from here to here is our 26.7, or 27, approximately 27 from the ruler. So the last one is 33.33. So we have all our lines drawn. You can see 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So the first focus point we have here is 15. So I will measure 15 from my ruler, that is 1.5. Measure 15 from the ruler, which is 1.5. Place at the focus. So I'm going to strike the corresponding. So this is my 15 or 1.5. Place on the focus. So I'm going to strike the corresponding value here. So on the focus and the value, this is our 10. So that's the first line there. Strike both up and down. So same way, I will go to 20. 20 of course will fall on the focus. So this is 20. Place on the focus, strike 20. So next one is 20, like I said. Place on the focus, you can see this is 20. Place on the focus, and the corresponding value here is 13.3, which is this second one. So next value here is 30. So extend my compass to 30. This is 30. Place at the focus, then strike the corresponding 20, which is the focus line. So next one is 40. Next one is 40. This is 40. Corresponding line is 26.6 at the focus. This 26.6 line. You take note of the point. Then lastly, we have 50. 50. Corresponding line is 33.33, which is the last one. So we take note of each point, and the curve must pass through the vertex. This vertex. So these are the points which we are going to be joining now with our French curve. These are my points. So I'm going to be joining this now with the French curve. So you are going to look for a perfect curve this way. So we join other parts together. So we have another part. We go to the next part. So we go to the final part. You can see this is my hyperbola with eccentricity of 3/2, always greater than 1. Thank you very much. God bless you. I hope you understand.